Hello and welcome to the course of Data Structures and Algorithms, CS221. My name is Dr. Zahid Halim and I will be your course instructor for this particular course, which is entitled Data Structures and Algorithms. My email ID is zahid.halim@giki.edu.pk, and this is my web page. Hopefully you guys will return back to the campus very soon, and then if you feel like visiting me other than the lectures which we will be taking in lecture halls, you can see me in G05, and these are my office hours. Now, the course TA for this particular course is Mr. Adam, and he will be responsible for marking your assignments and quizzes and maintaining the grade sheet and attendance and stuff on the CMS. So you never hesitate to visit the TA or me whenever you have a problem, and you must have noticed that I have mentioned the TA first here, and myself, I have mentioned myself second here. So if you have some petty issues like you would like to see some assignment, or maybe you would like to get some attendance fixed, so always first try to get it resolved by visiting your TA, and then if the issue is not resolved, of course you are always welcome to visit me, right? So although these are some rules which I apply in the physical or face-to-face mode of teaching, however, since they are mentioned here, so for the sake of completeness, let me read them out. Rather, this first one is it does not apply here in the case of online learning, so let us skip it. And this one as well, although I am communicating in the official communication language, but it does not apply to you, so let us skip this as well. And this last one also sort of, it does apply to you in online teaching mode as well, but maybe if you are using your mobile phone for watching the lecture or listening to the lecture, so practically it does not apply. But these two rules are very important, and since this you have just completed your first year at here at the institute, so you must have noticed that if you distinguish between yourself, provided you are a student who is on the average of the class, or most probably above average of the class, and if somebody is below average in terms of CGPA, in terms of your CGPA, so the principal differences between such students, the students who are better in terms of CGPA and those who are weak in terms of CGPA. So in the two principal aspects which basically influence this performance is that that a good student never miss his or her class. So the student always makes sure that they attend all the classes. So in terms of online lecturing, this is also applicable, that you must follow each and every uploaded lecture, and then of course interactive sessions, if we are having them, you should attend those as well. And secondly, you should never sleep in the class. For example, if you are listening to a lecture in the online mode, or maybe in the physical mode sitting in the class, so it's just listening is not enough. You should try to perceive and understand each and everything which the instructor is telling you. And the moment you stop perceiving what the instructor is saying, you should raise your hand and ask the question. And in terms of online teaching, of course, you have to wait for the interactive session, but as we did in the last semester, we had a chat group on WhatsApp, so you can raise your questions there as well. The books as such, if you recall, in the previous course, which was object-oriented programming, we used the C++ book of Detail and Detail as a reference book, although you were free to use some other book, for example, the book by Robert Lefort or someone else. But here in the course of data structure, we do not have one particular book which will be following, uh, because there are multiple concepts in multiple different books, and maybe some particular book explains a concept better than the other one, so I'll be referring to those. So in particular, I cannot refer to you one specific book, but if you want to purchase a book, I will strongly recommend to get this book. This is referred to as Bible of Algorithms, and it will be useful throughout your career during your BS, and maybe if you opt for masters or PhD. So this is a very comprehensive book, worldwide known author, Introduction to Algorithms, Corman. So we will not be covering this complete book, because there is another course named as Algorithms, Analysis of Algorithm, that is a separate course. In that particular course, this book is also used, but I strongly recommend, if you can purchase it, you can get it. But if you want soft copy of the book, you can drop me an email, maybe I can share that, right? Okay, now some policies, since it's the first lecture. So policies on dishonesty, plagiarism in quizzes and assignments. So my particular course always has a simple policy. If you are caught cheating, or there are strong evidences that you have cheated from somebody else, so you will not be getting 0, you will be getting minus 50% of the quiz or assignment or project. For example, if the project is of 10 marks, and in case you are proved guilty, then you will be getting minus 5, right? So better to avoid such situation, right? Of course, you will be crying as well if you, right? Then the attendance policy, as such, the attendance policy in online mode, I cannot enforce that, but like the previous course, I'll be creating link on the CMS, but since you know it takes at least 2 weeks from the start of semester to enable CMS function at its full throttle. So before that, I'll be a bit lenient about attendance, but after that I'll be making a link about each and every attendance, and you have to make sure that you upload your attendance there. And once we resume physical mode, then the institute's attendance policy will be applicable, right? Which is 100% attendance policy, right? Quizzes, of course, in the online mode, we are going for announced, but once inshallah we resume in face-to-face mode, we will be going for both of these, right? We will be having announced and unannounced quizzes. Of course, you know when you will be least expecting the quiz, so there will be the most probability of having a quiz that day. Now the tentative breakdown of this particular course in terms of marks or evaluation. So we'll be having around 8 assignments of 15% score in total. Approximately we'll be having 8 quizzes. I may take a couple of more so that we can have best 8 out of 10 quizzes. They will be having a total of 10% weight. We will be having a project with 2 phases inshallah, and it will be having 15% weight, and then of course one midterm of 20% weight, and one final of 40% weight. Again, remember, this is tentative. Most probably it will remain the same, but during the execution of the course, I may switch some weight from maybe assignment to quizzes or quizzes to assignment. So but most probably there are 99% chances that it will remain the same, but in case I change this evaluation, I'll be letting you know, sure. Now the course, of course I've made this particular slide for the face-to-face mode. So uh, we will be having 3 lectures once we resume face-to-face. Otherwise I'll be in each week, maybe on each weekend I'll be uploading 3 lectures maybe together, and you can throughout the week, you can anytime at your own convenience, you can see those lectures. And course website, of course, course material, slides and assignments and the reading stuff will be uploaded at CMS, right? Once we resume, inshallah, in the face-to-face mode, then you will be following the course schedule distributed by the controller of admissions and examination office, right? Now this is the overall outline of the course, and this is the basically the course covers a lot more than these few topics, but these are the a couple of key topics which we will be covering in this course. For example, we will be starting with introduction, which is today's lecture. Then we will be having the algorithmic analysis. So far what you guys have done, you have created programs. For example, if you felt like using a for loop, you would use for loop maybe, and if you felt like using a while or do while loop, you would have used that. But in this analysis algorithm, we will try to analyze one piece of code in comparison to another piece of code, and we will see which piece of code is better than the other one, right? Both of them will be performing a particular task. For example, these both algorithms are for sorting, and both of them will be working perfectly, but we will be analyzing their performance. So there are particular techniques in the analysis of algorithms. Those techniques we will be covering here, right? Then abstract data types, I will be covering those. And then there is a particular data structure known as list. If I'm not very wrong, we studied the linked list in our object-oriented programming course. So we will be revisiting those lists as well. Then we will be creating stacks. I think we studied this as well, but we will be studying it in detail here in this course. If you recall, I think we studied the topic of template, function templates, class template. In that we studied the stack, how the stack works, and we'll be studying queues as well. Then there is another data structure called trees, and if I visualize the tree, it is something like this, right? So in memory it is placed like this, and the information is stored in these nodes. For example, here some value is stored, here some another value is stored, here another value is stored, and this is how this can be logically visualized on the screen. So we'll be covering trees as well, and there are a lot of type of trees. For example, there are binary tree, binary search trees, B trees, and red black trees. So there are a whole lot of trees which we'll be covering in this course. And there is another technique which is called hashing. So hashing we'll be covering in this course as well. This is a very important concept when it comes to making, although other concepts contribute to this as well, but when it comes to making code which works very quickly in terms of searching, or in terms of searching a few items. So this hashing works perfect at its optimum. So we'll be doing that as well. Queues I already have discussed there, but we'll be having some real world case studies of these queues. Then sorting, there are so far, if I'm not very wrong, you only know about bubble sort, but there are many other sorting algorithms: quick sort, merge sort, bucket sort, linear sort, so on and so forth. So we'll be covering a lot of sorting algorithms as well. And then graphs is a very important concept. So, and there are many algorithms which are there in graphs. So for example, to visualize a graph, this is a graph, right? Although I have made it very haphazardly, but this is a graph, right? So how do we make a graph, and how a problem is translated into a graph, then how the graph is stored in a particular data structures, and then there are multiple algorithms, like for example finding a path from one place to another, when the map of the, let's say, a city or a country or a place or a town is represented as a graph. So there are a lot of graph algorithms which we'll be covering in this particular course, and then there are some algorithm design techniques which are also part of this particular course. Again, I have not explicitly mentioned each and every topic to be covered in this particular course, but this shows a basic crux of what this course is about. So basically this course is about giving you an extra list of understanding about available data structures and their performance, so that you can solve any problem, you can solve it more efficiently, right? Okay, now this particular slide I'll be skipping, right, because this is a motivation which I used to give in the face-to-face mode of the lecturing. So maybe when you return I'll be covering this slide, right? So you have to wait for that. And again, if you cannot wait, make up a story of your own. Okay. So now coming to what exactly a data structure is. Now think for a while, and what will be a data structure exactly, right? So if we think about computers, what is a computer? Computer takes something as an input, maybe two numbers, right? And then what it does some mysterious processing and produces an output. And if most probably if it is taking two numbers, maybe it is adding those numbers, or maybe multiplying or dividing, whatever. So internally this mysterious processing happens, right? So this here in this particular place we will be having two things. One, we will be having our code. You may write it in C++, you may write it in Java, and whatever language you like. And then we will be having some memory locations. We'll be having some memory location which will actually store the variables or data which we are doing, and this code will actually execute, will fetch items from the memory and do multiple processing, right? So if we decode that what this particular processing is which happens inside the computer, so this basically okay, let me go to the next slide and then I'll be covering that. So this basically is two things. One is the data structures and the other one is the algorithms, right? So these algorithms can be referred to as your code, program, you call it program, you call it code, or whatever, right? This is the code, and this is the memory locations. This is the memory location which actually stores some numbers or set of numbers, or maybe some text data or whatever. So both of these combine together to form a program, right? Now not every variable can be stored in a single variable. Not every variable can be, or not every data can be stored in an array, or maybe in a stack or a queue. So this data structure actually provides you a list of a broad list of multiple available memory structures called the data structures, where you can store your data according to your own requirements, so that your program is actually handled efficiently and effectively, right? By efficiently we mean it should be quick, and effectively means that the data which you need to store should be should easily get fit into the particular data structure. For example, some data may be suitable to be stored in a tree. This is a tree. I'll be going into the details of how a tree is made in a data structure and how it works, but for the higher level of understanding, let's assume that you already know what a tree is, although you don't know, but it looks something like this, right? So for example, if I want to store an equation a plus b, for example, right? So in this particular case, array and linked list may not be a good choice. This tree may be a good choice. For example, you can place a here, now plus sign here and b here. So in this way you have efficiently stored this equation here, and when you want to retrieve it, you can retrieve it easily in this particular form. There is a particular order which is called to traverse a tree, that is called in order traversal. And again, you don't know, I have not told you about what is an in order traversal, pre order traversal or post order traversal in a tree. So if you do not understand, don't worry, there is a complete separate lecture on that, we will be covering it there. But I just want to make sure that you understand the importance of storing the data efficiently and effectively in the in a particular data structure. So here you are storing the data efficiently, no information is lost here, and the information can be retrieved at your own convenience from the particular data structure. So these are 5 different data structures, and there are a lot more. This is an array, linear array, which you have studied from your CS121 course, and this is the linked list which you were introduced to in your CS112 course. And now this is a tree which you were never introduced to, but you will be covering in this particular course. Queue and stack, you have some idea about this, right? So this is how the mysterious processing happens in the computer. So the data structure, which is this stuff, plus the code algorithm, which is used to store the data in this data structure, or maybe search the data in this data structure, or maybe update the data structure data in this data structure, or maybe delete some particular data in this data structure, right? So it is used for that, and then it will be producing an output, right? So the definition of a data structure is that a data structure is the logical or mathematical model for a particular organization of data, right? So it is either logical or mathematical. If you see here, in terms of for example, this is a mathematical form placement of data. For example, at index I, for example, index 0, index 1, index 2, index 3, and so on and so forth, we are placing data consecutively one after another, right? And if you see here for example, if we say that this is a parent node, and let's say this is child 1 and this is child 2, so here this is a logical placement of items. For example, this parent has 2 child, so it's one child is here, one child is here, and then we can refer to this child as maybe grandchild, right? So it is grandchild of this parent, and it is actually the child of this parent. So the data structure is logical or mathematical model of a particular organization of data, which we do in the memory. But it must be rich enough to mirror the actual relationship of data in the real world, right? For example, if I have an equation, and let's see, I have an equation a plus b, right? Okay, excuse me for my bad writing. And if I want to store it in some data structure, so then we can use a tree where we know that between a and b there is an operator called plus, right? So this data structure is rich enough to maintain or mirror the actual relationship of data in the real world, right? Again, I have given you a simple example here. I could have given you a complicated example, but for the introduction lecture, that may not be very useful here. So array, let's say this is simple example of a data structure. This is a linear array, or you can call it linear array, or maybe 1D array, one dimensional array. Now if you see here in the memory, if you treat this complete 2D array as RAM, okay, RAM or a M. Now here this is one array which is stored here, this is another array which is stored here, and then this gray colored array, this is yet another array which is stored in the memory, right? So arrays are stored. This is this format of storage of array is called the column measured, right? It is stored column wise. But if you see here, this is row measured. So this totally depends upon the particular compiler or the way you have written the code. So these are the internal details, but if we want to store the array, we simply use the programming languages, and whether it stores it in column measured form or row measured form, that remains invisible to us, right? Now if you see here, this is a 2D array where we have rows and we have columns, right? And this is yet another 2D array where we have like this column and this column, and then this is a linked list, right? A bad example of a linked list, honestly, because I think it should have been had some arrows so that one could see that which is the start node or which is the end node, but don't worry, I'm making those arrows here, right? And if you see here, and this should maybe the null, right? Now if you see this linked list, this is in this complete memory. One node is placed at one particular location, the other one is placed at the next location, and so on and so forth. So the linked list nodes are not placed consecutively in the memory. But again, it is a different data structure, and it may be useful for some problems, and maybe say in some problems this 2D array may be useful. And then this is a tree data structure with another example where the address of an employee is stored, right? Where one of the nodes, this is the parent node of the tree, and don't worry if you cannot understand that how I will be creating this tree and how I will be storing, but don't worry about that. We have totally different lectures, comprehensive lectures on that. So I'll be from the scratch, I'll be telling you, and maybe I will be coding it for you, that how these trees are created in the memory and how we access their values. So for the sake of this particular lecture, just focus on the structure of the tree instead of thinking about the details. We will be covering those details when we reach this particular topic. Now if you see here, this is the parent node and this is child node. Depending upon the type of the tree, we may have many number of child of a particular tree, but there is there is a type of the tree which is called binary tree. In binary tree, every node can have a maximum of 2 children, right? It cannot have, in a binary tree, it cannot have third child, right? But again, if we say that it is a generic tree, we are not restricting, we are not saying that it's a binary tree, then a tree can have as many children as it would like to have. But again, if you think about implementing it, binary tree, restricting the number of child of a particular tree will be convenient for you in terms of coding, right? But I am not going into the detail of coding at present. In the lectures on detailed lectures on tree I will be of course covering that. Now if you see this tree here, it says employee and one child is name, one is age, one is address, and one is salary. So if for example name is, let's say, Ali, the value Ali will be stored here. If age is, let's say, 27, it will be stored here. Address, now this is further subtype, so maybe the thing is stored here. Salary, for example, okay, let us give him good salary, 79,000. Okay, I think it is enough for him. Now maybe, and then this name has further first name, last name, so maybe here Ali is not stored, maybe here we can store like Ali Noman. Okay, excuse me for my writing, right? And so so on and so forth. So again, this is another data structure which makes storage convenient for us, right? If you see here, here we have stored an equation in a tree, right? So if you see here, now if you take this segment, now this segment is represented by this particular set of trees. So the plus is between this portion and this portion, the plus is here and y is here, and then these two things are getting multiplied, so steric is between 2 and x. Now, but again, this is an example of how we use tree. Don't worry about how we will actually be storing our data in the form of this tree. When we come to the topic, I'll be explaining that, and then it will be very convenient for you, right? So I think so far it is sufficient for the introductory lecture, and I'll be getting back to you in the next lecture. Thank you.